What if I told you that the syrup you eat with your pancakes every day can actually explain how the whole universe works? Well, not exactly. Let me explain.
See, quantum field theory tells us that the universe is filled with quantum fields, with particles constantly moving through them like a wave moving through the ocean.
Now, this theory was perfect for quantum electromagnetism, but when it came to the other forces of nature, it failed.
This is because the theory didn't allow for particles to have mass, which is necessary for specific interactions, without breaking the symmetry of the equations involved.
In came Peter Higgs, the physicist who proposed the Higgs field.
This revolutionary field created the concept of spontaneous symmetry breaking, where the field transitioned from an unstable but symmetric state to a stable configuration that broke the initial symmetry. The mass symmetry dilemma was finally solved.
But what does that have to do with syrup or the universe?
Well, it turned out that Higgs's original proposed theory was actually the mechanism by which all fundamental particles gain their mass. See, particles can actually interact with quantum fields beyond their own, similar to how a student has classes with their own grade but can interact with the grades above or below them. Now this is where the syrup comes in. Imagine that this tub of maple syrup here is the Higgs field. Let's also say that these mixed fruits represent different particles interacting and moving through the Higgs field. Now some particles, like photons, don't interact with our syrup field at all, which means that they remain massless. Other particles though, like electrons, do interact with our field. Similar to how the fruits that interact with the tub gain a layer of syrup and thus an added mass, particles that interact with the Higgs field gain energy that gives them their mass. The amount of mass they gain depends on how strong the interaction is. Particles that move quickly through the syrup will interact weaker and gain less mass than particles that move slowly through the field and thus interact strongly.
So why is mass even important to the universe?
Well, without particles having mass, we would have nothing. See, if electrons didn't have any mass, they couldn't form hydrogen atoms with protons because there would be no electromagnetic force.
No hydrogen atoms means no stars, no moons, no planets, no galaxies, no universe! The next time you're eating pancakes, maybe you'll remember Higgs's juicy syrupy field, because without it,